Hello everyone. In this session we discuss about knapsack problem. Knapsack problem is an optimization problem. What a knapsack problem states that given a set of objects which have both a value and weight, what is the maximum value we can obtain by selecting a subset of these objects such that the sum of weights does not exceed a certain capacity. Suppose we take this example. Now knapsack has many real-time applications. We see one of the application airports when we go to other countries. Those flight people, they allow only certain weight. Suppose I try to carry more than given weight, they won't allow. What we do, we try to optimize our carry bag. Now here knapsack is nothing but it's like a bag type, but the capacity of knapsack is 7 kgs. Now I have 5 items to put in this bag. Each item has its own value and weight. Suppose one item is its worth as $2 and its weight is 3. Another item worth is $2, its weight is 1 kg, 3 kg, 2 kg, 4 kg. Now our problem is that we have to select these items based on their weights in such a way that if you if you make a sum of all the items, it should not cross 7 kg. Means what are the maximum value? What is the maximum value you can achieve to keep those items in the bag? Which way we select? Suppose here I say 4 and 3. If I keep these 2 items in the bag, it's okay, but I am achieving value of only 5 plus 2, $7 only. So suppose if I select 2, 4, I select it's only 4 kg. Suppose I keep these 3 items together, it 1 kg, 4, 6 kg. But it's if I keep these 3 items, I am achieving a 3 plus 7, $9 value. Here I am achieving $7 value, you are achieving $9 value. So which items we keep this in this bag to get the highest value? That is my objective function of this optimization problem. How we arrange? Suppose somebody select 5, this item 5 and 3, this 4 kg and 2 kg is allowed, but we are achieving $8 value, but we are wasting 1 kg space. Like this, knapsack basically, here we have to keep the items in the bag in such a way that weight of all the items should not cross 7 kg, and after keeping those items, I should achieve maximum value of my items. So how we can solve this problem in using hill climbing algorithm? So knapsack, initially I formulated the problem. Input, it takes input to n items. Each item has its own value and its own weight. Objective is select a subset of items to maximize the total value while ensuring the total weight does not exceed the given W. In our case 7 kg is the total weight. No, if I combine all those items, it should not cross 7 kgs. Like that, I have to select the items. Constraint. You have to include the item entirely at once, means no fractional part. Suppose if I say I can say 5 plus 4, I am getting $9 value. So if I want to keep, I cut down 4 into 2 fractional parts. We can't do it. If you are keeping the item, means you have to keep entire item in the bag. So that is one constraint. So this is how I am representing my problem before starting giving a solution to the problem. Now hill climbing, as I told you, hill climbing climber algorithm. This algorithm first takes initial state. Here it uses 0 1 knapsack. Knapsack here state I represent it as a 1 1 0 1. That means we see the problem. Suppose these are the items 10, 20, 30 are their values. There are 5 items I have to keep in the bag. Each item value, first item, second item, third item, fourth item, I kept them in 0 to 4 indexes, and their weights, first item has a 10 value and 5 weights, 20 value, 10 weights, like that I represented it as an array. Now my constraint is capacity is 50. Now first I select the items 2, 3, 4. Means in a 0, 1, 2, 3, 4. 1 means I selected the items, 0 means I have not selected that item. That means I selected 2, 3, 4 means 30 plus 40 plus 50, 120. Value I am achieving value 120. If I calculate the weight 60, but my given constraint means my bag should contain only 50 kgs, but it is giving 60. It is infeasible, means I cannot divide into fraction. I have to maintain exactly 60 only, which is not feasible. So what I do, better I select the items 1, 1, 0, 1, 0. That means first item 0, 5, second item 20, and fourth item 40. They are selected values. Their value is 5, but their weights are 35, less than or given 50. Here this is a feasible solution because I am getting 35, which is less than or equal to 50, but here value I am getting only 70. Here I am getting value as 120. So what we do, we have to find optimum solution, like optimization or optimum solution that can that is feasible, which is less than 50, and that gives the highest value of my items. So initial states I represent it as 1, 0, 1, 0, 1. As I said, this is the first item. I selected first item, third item, and fifth item. Their values, when I combine their weights, 90, 45 less than or equal to 50. Now I calculate a fitness score, 90 feasible, because 45 less than or equal to 50, it is satisfying our constraint, so it is feasible. I accepted this as my current state. From this current state, now I generate a neighbor state. How I generate neighbor state? I just a second one I flipped from 0 to 1. This is a new state I created. For this I get 55 as a kg, 5 kg more. So its fitness is 0. So again I create another neighbor state. Here earlier I swapped only 1. This time flip bit 2 from 1 to 0. So this is a neighboring state. These 2 bits, earlier only 1 bit, now 2 bits are flipped to 0. I created new neighbor state. For this neighbor state I am getting 30 less than or equal to 50. Its fitness is 60, but value is also very less. So I make another neighbor again, flip bit 3. So this is first, this is the state I got from initial state. Making a slight changes, I got this state by flipping values. By flipping values in this state, I got this state. Now what I do, here next 2 bits are flipped. The second up, next 2 bits are flipped. Now what is the value? I get 80 and 40. This is the best solution because I am getting highest value and it is within the limits of 50. So I achieve the fitness of 80. So like this we continuously select a new neighbors and calculate their fitnesses, and whoever gives the high value and less than 50, they are selected as a optimized solution. So finally I got this after making so many neighbor state, selection of neighbor state 1, 1, 0, 1, 0. This is the best one, that is giving 35 and 70. So like this we solve a knapsack problem using hill climbing algorithm. So remaining algorithms like simulated annealing, generating algorithm, you please go through my previous sessions on classes and you can easily solve this problem using those techniques. Thank you.